In October 2019, astronomers at the Cerro Tololo Inter-American Observatory in Chile were conducting routine observations when their instruments detected something that should have been impossible. A star they had been tracking for months simply blinked out of existence. Not dimmed, not faded, vanished. For 73 days, the coordinates where this star had blazed for billions of years showed nothing but empty space. Then, without warning, it reappeared. But here's where the story becomes truly disturbing. When astronomers triangulated its new position using multiple observatories across 3 continents, they realized something that sent shockwaves through the astronomical community. The star had moved, not drifted slowly over millennia, as stars do. It had shifted position by nearly 2 arc-seconds. That's the equivalent of an object changing its location by hundreds of billions of miles instantaneously. No known physics can explain this. Stars don't teleport. They don't vanish and reappear like cosmic magic tricks. And yet, in our supposedly well-understood universe, this is exactly what happened. The implications are staggering. Either our fundamental understanding of stellar mechanics is catastrophically wrong, or we've just witnessed something that operates outside the laws of physics as we know them. This isn't the first time. Between 1952 and now, at least 17 similar events have been documented. Objects that were there, then weren't, then were again, but wrong, displaced, moved. The phenomenon has been given a name by the handful of researchers brave enough to study it: variable sky objects. And the more scientists investigate, the more terrified they become. Because if stars can simply vanish and reappear elsewhere, what else might be moving through our universe undetected? To understand how we got here, we must go back to a time when we thought we had the cosmos figured out. For thousands of years, humans believed the stars were fixed points of light, eternal and unchanging, painted onto a celestial dome that rotated above us. The ancient Greeks called them the fixed stars to distinguish them from the wandering planets. This view persisted until 1718, when astronomer Edmund Halley made a disturbing discovery. By comparing ancient star catalogs with his own observations, Halley realized that several bright stars, including Arcturus and Sirius, had moved from their recorded positions. The heavens weren't fixed at all. They were in motion, but Halley's stars moved predictably, tracing paths across the sky over centuries according to Newtonian mechanics. Their motion could be calculated, forecasted, understood. What happened in 2019 was different. This was instantaneous displacement with no transition period, no trail, no physical journey through space. It violated everything we thought we knew. The foundation of modern astronomy rests on a simple assumption. Objects in space obey consistent physical laws. They move in predictable ways governed by gravity, momentum, and thermodynamics. When Albert Einstein published his theory of general relativity in 1915, he provided the mathematical framework that described how massive objects curve spacetime and how this curvature determines motion. For over a century, every observation has confirmed Einstein's equations. Planets orbit stars, stars orbit galactic centers. Galaxies cluster and separate according to the expansion of spacetime itself. The universe operates like clockwork on cosmic scales. Then came digital sky surveys. Starting in the 1990 seconds, astronomers began systematically photographing the entire visible sky night after night, creating massive databases of stellar positions. Projects like the Sloan Digital Sky Survey and later the Gaia Space Telescope mission mapped billions of stars with unprecedented precision. The goal was to create a comprehensive census of our galaxy, to track stellar motion, to find new objects. What they found instead was Anomaly. In 2003, a team reviewing archival data from the Palomar Observatory discovered something odd. A moderately bright star catalogued in their 1952 survey simply didn't exist in their 2003 images. The star had vanished. But here's what made this case extraordinary. When researchers checked observations from 1995, the star was still there. Somewhere between 1995 and 2003, it had disappeared. This sparked a systematic search through 70 years of photographic plates and digital images. The results were deeply unsettling. Across multiple independent surveys, researchers identified at least 17 objects that had vanished from the sky. Not exploded into supernovae, which would leave observable remnants, not gradually dimmed as dying stars do, simply gone, erased from existence. Meanwhile, across the world, a Swedish team at the Nordic Optical Telescope was developing algorithms to detect transient astronomical phenomena. These computer programs could compare millions of images, flagging anything that changed position or brightness. In 2016, their system detected something that the lead programmer initially dismissed as a software error. An object appeared in one frame, vanished in the next, then reappeared 3 frames later, displaced by 1.8 arc seconds. The programmer ran diagnostics. No error. The cameras had worked perfectly. The algorithms had worked perfectly. Something in the sky had genuinely moved in a way that shouldn't be possible. By 2018, astronomers had identified a pattern. These variable sky objects, as they came to be called, exhibited specific characteristics. They were typically faint to moderately bright stars. They vanished for periods ranging from hours to months, and when they reappeared, they were always displaced from their original positions. The displacements ranged from fractions of an arc second to several arc seconds, representing distances of trillions to hundreds of trillions of miles. The astronomical community faced a crisis. How do you explain something that violates fundamental physics? The first instinct was to blame observational error, perhaps atmospheric distortion, instrumental malfunction, or processing artifacts created the illusion of displacement. But by 2019, with observations from space-based telescopes that bypass atmospheric interference entirely, that explanation crumbled. The Hubble Space Telescope confirmed 2 separate vanishing events. The objects were genuinely disappearing and reappearing. The phenomenon was real. The first chapter of this mystery centers on what astronomers call the October event, the 2019 disappearance that opened our story. The star, designated Vela J 835 in astronomical catalogs, was a red dwarf located approximately 47 light-years from Earth in the constellation Vela. Red dwarfs are the most common stars in our galaxy, small and stable, burning their hydrogen fuel so slowly they can exist for trillions of years. They don't behave erratically. They especially don't vanish. Vela J 835 had been photographed thousands of times since its inclusion in catalogs in the 1,960 seconds. Its position had been measured with extraordinary precision by the Gaia spacecraft, which uses parallax measurements accurate to within millionths of an arc second. On the 9th of October 2019, routine observations showed the star exactly where it should be. On October 10, it was gone, not dimmed to invisibility. The space where the star had been showed cosmic background radiation consistent with empty space. For the next 73 days, multiple observatories monitored those coordinates. Nothing. Then on the 22nd of December 2019, the star reappeared. But when astronomers cross-referenced its position against Gaia's measurements, they realized it had shifted. The new position was offset by 2.1 arc seconds from the original location. 2 arc seconds might sound trivial. It's barely perceptible to even the most powerful telescopes. But at 47 light-years distance, that angular displacement translates to a spatial displacement of approximately 450 billion miles. That's nearly 5,000 times the distance from Earth to the Sunday. The star had somehow moved this impossible distance while completely invisible to our instruments. No physical process can explain this. Stars move through space at velocities measured in kilometers per second. Even at an absurdly high velocity of 1,000 kilometers per second, a star would need over 24,000 years to cover 450 billion miles. Vela J 835 did it in 73 days. And more disturbing, there was no Doppler shift in its light spectrum suggesting high-velocity motion. The star wasn't moving through space in any conventional sense. It had simply relocated. In 2021, the European Southern Observatory's Very Large Telescope in Chile conducted follow-up observations. They analyzed the star's spectral signature, its composition, luminosity, and rotation rate. It matched archival data perfectly. This was definitely the same star. Same chemical composition, same temperature, same stellar classification. It hadn't been replaced by a different star. The original star had genuinely moved. Dr. Maria Contreras, lead astronomer on the observing team, told colleagues in a leaked email that analyzing this data gave her the worst existential crisis of my career. She wrote, "We have a star that violated causality. It was in position A, then ceased to exist, then was in position B. No light speed travel between positions, no physical mechanism. It's as if the universe copied, deleted, and pasted a star." By 2023, researchers had identified 3 more stars that exhibited similar behavior. Each vanished for periods ranging from 12 to 91 days. Each reappeared displaced from their original positions, and each time, the displacement occurred without any observable transition through the space between positions. The second chapter of our investigation takes us to an even stranger discovery. While studying these variable sky objects, astronomers noticed something else. Some of the vanished stars didn't just reappear in new positions. They reappeared in the past. In March 2022, the Zwicky Transient Facility at Palomar Observatory detected a star that appeared in images taken weeks earlier, but hadn't been visible in real-time observations conducted during that same period. Imagine photographing an empty field, then weeks later reviewing the photograph and finding a person standing there, even though you know for certain the field was empty when you took the shot. That's essentially what happened. The technical term is retroactive appearance. When astronomers compared archival data stored on computer systems with identical archival data stored on physical photographic plates, they found discrepancies. Digital files showed stars that weren't present on the original plates. At first, researchers assumed data corruption or cyber attacks had altered the digital records, but forensic analysis of the storage systems revealed no intrusions, no modifications, no tampering. The files appeared to have always contained these images, except the physical plates proved they hadn't. Something was altering the past, not metaphorically, actually changing what had been recorded. This discovery emerged from the VASCO project, the Vanishing and Appearing Sources During a Century of Observations, an international collaboration specifically organized to study these phenomena. VASCO researchers systematically compared modern astronomical surveys with photographic plates dating back to the 1,950 seconds. Their methodology was rigorous. Identify sources present in old surveys, check if they still exist in modern surveys. Identify sources in modern surveys, check if they existed in old surveys. The expectation was to find stars that had died, exploded, or simply moved out of frame over decades. Instead, they found stars appearing in modern data that provably didn't exist in historical data. And they found historical data that now showed stars which earlier analysis had recorded as absent. In November 2023, a paper published in the Astrophysical journal documented 12 cases where stellar objects appeared in archival photographs only after their discovery in recent surveys. The paper's conclusion was extraordinarily careful, hedging its language, but the implication was unavoidable. Either our observational records are fundamentally unreliable in ways that defy all known causes of unreliability, or something is manipulating astronomical data across time. The paper's lead author, Dr. James Chen from Stockholm University, received threats from colleagues accusing him of promoting pseudoscience. His response was simple: "I'm reporting observations. If the observations seem impossible, that's not my fault. That's physics' problem." The third chapter brings us to the most recent and perhaps most terrifying development. In January 2024, the James Webb Space Telescope was conducting deep field observations of a region containing several variable sky objects. JWST's infrared instruments can detect objects invisible to optical telescopes, seeing through dust and gas, revealing hidden structures. When JWST trained its mirrors on coordinates where a star had vanished 6 months earlier, it detected something. Not the star, something else, a structure. The initial description in internal NASA communications called it a spatial discontinuity. Imagine looking at a photograph and finding a section where the image seems cut and pasted from a different photograph. The background stars don't quite align. The color balance is slightly off. That's what JWST detected. a region of space roughly 3 light-years across where space-time itself seemed wrong. Further analysis revealed that light passing through this region underwent aberrations inconsistent with any known gravitational or electromagnetic phenomenon. Photons entering the region from behind appeared to slow down, not in the relativistic sense of time dilation near massive objects, but actually losing energy for no apparent reason. Then they crossed some threshold and returned to normal propagation. It was as if space itself had different physical properties in that region, as if the fabric of space-time had been patched with fabric from somewhere else. Physicists have a term for this, a topological defect. These are theoretical structures predicted by some quantum field theories. Regions where the fundamental fields of nature are twisted into configurations that create bizarre effects. Cosmic strings, domain walls, monopoles, these are all topological defects that might have formed in the extremely early universe. But they're supposed to be incredibly rare, relics from fractions of a second after the Big Bang. Finding an active topological defect near a variable sky object suggests something profound. By mid-2024, JWST had identified 17 spatial discontinuities. Every single one corresponded to locations where stars had vanished. The correlation was perfect. 100%. This couldn't be coincidence. Whatever mechanism causes stars to vanish is creating these defects. Or perhaps the defects were always there, and stars are falling into them. Either way, we're looking at regions of space where physics operates differently, where the rules change. In August 2024, a classified briefing was held at NASA headquarters. Details leaked gradually through networks of researchers. According to sources present, the briefing presented evidence that the discontinuities are growing, expanding. The region JWST, first observed in January, measured approximately 3 light-years across. By August, it measured 3.4 light-years. In astronomical terms, this expansion rate is absurdly fast. If it continues, the discontinuity could engulf nearby star systems within centuries. And here's the deeply unsettling part. We don't know how many of these discontinuities exist in our galaxy. We've only detected the ones associated with vanishing stars we happen to be observing. There could be thousands, millions, an entire hidden architecture of broken space-time threading through our galaxy, invisible until something falls into it. This changes everything we thought we understood. For centuries, astronomy has been the most predictable of sciences. Calculate an orbit, predict an eclipse, forecast a conjunction, and the universe delivers exactly what the mathematics promised. That reliability made us confident, perhaps too confident. We assumed the universe played by consistent rules everywhere, at all times. We built our understanding of cosmology on that assumption. Dark matter, dark energy, the expansion of the universe, the formation of galaxies, all of it rests on the belief that physical laws are uniform. But what if they're not? What if our galaxy, perhaps even our local region of space, contains zones where different physics applies? Regions where stars can move discontinuously, where causality breaks down, where the past can be altered? This isn't speculation anymore. We have observations. We have data. We have instruments operated by the most sophisticated space agency in human history detecting phenomena that shouldn't exist. The implications spiral outward into increasingly disturbing territory. If space-time can develop discontinuities, if regions of altered physics exist in our universe, then everything we think we know about the cosmos might be true only locally, only in the particular patch of well-behaved space-time we happen to inhabit. Travel to a different region of the galaxy, and mass might work differently. Light might propagate at different speeds. Time might flow backward. We've been astronomers studying a single neighborhood and assuming the entire city operates the same way. But the city might be far stranger than we imagined. Consider the implications for interstellar travel. Any spacecraft venturing beyond our solar system could encounter these discontinuities. What happens when a ship crosses into a region where physics changes? Do the fundamental forces holding atoms together remain consistent? Would the ship simply vanish like these stars, reappearing somewhere else, someone else? Humanity's dreams of exploring the galaxy suddenly face a threat we never anticipated. Not hostile aliens or impossible distances, but the universe itself being fundamentally unstable. And there's a darker possibility that researchers discuss only in private conversations, never in papers, never on the record. What if these discontinuities aren't natural? What if they're artificial? The precision of the vanishing events, the way stars reappear in calculably different positions rather than random locations, suggests mechanism, not chaos. Some researchers have quietly begun investigating whether these could be engineered structures, technologies so advanced they can manipulate space-time itself, creating shortcuts through space, folding reality to move objects instantaneously. It sounds like science fiction. But then, so did stars vanishing and reappearing until we observed it happening. But the greatest mystery still remains. Why now? If these discontinuities are ancient structures from the early universe, why are we only detecting them in the last 20 years? If they're newly forming, what's causing them to appear now? Has something changed in our region of the galaxy? Is some process accelerating? Are we passing through a region of space where these defects are more common? Or has humanity simply reached the technological threshold where we can finally detect something that's been happening all along, invisible to earlier generations? The timing disturbs astronomers. We've had telescopes for 4 centuries. We've had photographic surveys for over 100 years. We've had digital sky surveys for 3 decades. Yet only in the last 20 years have variable sky objects been detected. Either we've been extraordinarily lucky to witness the beginning of a new cosmic phenomenon, or we've been extraordinarily unlucky to develop observation capabilities just as something catastrophic begins. The future of astronomy has shifted. Projects designed to map the universe, to study galaxy formation, to search for exoplanets, are now being quietly repurposed. A growing faction of researchers believes that understanding variable sky objects is the most important problem in contemporary astrophysics, more important than dark matter, more important than dark energy, because those mysteries, however profound, don't threaten the fundamental stability of space-time itself. NASA's next flagship telescope, currently in development with a planned launch in the early 2032, is being designed with specific instruments to detect and study spatial discontinuities. The European Space Agency is planning a mission to send probes to regions where variable sky objects have been detected, using swarms of small spacecraft to map the discontinuities in detail. China's space program has announced a dedicated observing campaign using their growing network of ground and space-based telescopes. For the first time in decades, the world space agencies are coordinating on a single scientific priority. The message is clear. This is urgent. What scientists are working on now isn't just cataloging these events, it's understanding the mechanism. Theoretical physicists are developing new models of spacetime that allow for discontinuous topology, regions where the smooth fabric of Einstein's universe develops tears and patches. These models are exotic, requiring modifications to general relativity that physicists have long considered unnecessary. But observations are forcing theory to adapt. If stars can vanish and reappear, then the mathematics must accommodate that reality, no matter how uncomfortable. Experimental physicists are proposing laboratory tests. Can we create miniature discontinuities in controlled environments? Can we manipulate space-time topology on quantum scales and study the effects? These experiments would require energies far beyond current particle accelerators, but they're theoretically possible. Understanding the mechanism might take decades, or centuries, or we might never understand it, might simply have to accept that we live in a universe far stranger and more dangerous than we thought. The human dimension cannot be ignored. When the news of variable sky objects eventually breaks into public consciousness, and it will, these things always leak. Humanity will face a profound psychological crisis. We've built civilization on the assumption of cosmic stability. The stars are eternal. The universe is predictable. Our planet orbits safely in a well-understood cosmic environment. Learning that stars can simply vanish, that space-time can tear, that the universe contains zones of altered physics will shake that confidence. It already has for the astronomers who know. Many report feeling unmoored, anxious, questioning whether our existence is more precarious than we realized. If stars can vanish, could our sun vanish? Could Earth itself fall through one of these discontinuities? The statistical probability is vanishingly small. We orbit a stable star in a seemingly normal region of space, but vanishingly small isn't zero. And that uncertainty, that knowledge that the universe can do impossible things, changes how we see our place in it. Because in the end, we're faced with a truth that ancient astronomers understood intuitively and modern astronomers forgot in our rush to mathematize the cosmos. The universe isn't tame, it isn't fully knowable, it isn't safe. We live on a small world orbiting a small star in a galaxy containing hundreds of billions of stars, and somewhere out there in that immensity, the rules break down, physics fails, reality becomes negotiable. We've cataloged 17 variable sky objects. We've detected 17 spatial discontinuities, but we've only surveyed a tiny fraction of the galaxy. How many more are out there? How many stars have vanished that we weren't watching? How many regions of broken spacetime exist in the darkness between stars? We don't know. We might never know. And perhaps the most terrifying thought of all, if stars are falling through these discontinuities, where are they going? Are they simply destroyed, their matter and energy annihilated, or do they emerge somewhere else? In another part of the galaxy? Another galaxy? Another universe entirely? Could the star that vanished from our sky have reappeared in someone else's? Could there be other astronomers, light years away, watching in horror as strange stars suddenly appear in their heavens, stars that don't belong, stars from elsewhere? The universe, it seems, is more connected and more mysterious than we ever imagined. The stars above us aren't fixed. They're temporary visitors in our sky, and some of them are already leaving. We just don't know where they're going, or what's taking them, or whether, one clear night, we might look up and find that our own sun has joined them, vanished into the dark, leaving us to tumble through space around a star that's no longer there, because in the end, the universe always has another secret waiting, and this one might be the darkest secret of all.